Dear student, myself Rajendra Aaseri, I am Assistant Professor in Computer Science Department at Government Bangad PG College, Didwana. In the previous lecture, we discussed about the relation, various ingredient of a relation, what is the meaning of attribute, how to ensure that the attribute is having a atomic value, what is domain, what is tuple, record, all these concept we already have been discussed in the previous lecture. We have discussed about various levels of abstraction, we discussed about database design techniques, relation schema, relation instance. Okay. Now in today's lecture, we will be focusing on some new concept about the database. So starting with the concept, a new concept, that is key. Let key is a subset of the relation R, right? So key, I am giving the notation K, and relation I am giving the notation R, right? Key is a super key of R. K is a super key of R if values for K are sufficient to identify a unique tuple of each possible relation R. Okay. So if I'm saying that K is a super key if it is sufficient to identify the unique tuple of each possible relation of the R. By possible R, we mean a relation R that could exist in the enterprise we are modeling. Okay. Example, suppose I'm saying customer relation, three attributes are there: customer name, customer street, and customer ID. It is written here wrong. Here customer ID. First one is ID, second is street, and third one is name. Okay. So if I'm saying that in case of the customer table, I can distinguish with help of customer name and customer street, or single customer name are both super keys of the customer if no two customer can possibly have the same name. In real life, an attribute such as customer ID would be used instead of customer name to uniquely identify the customer. Okay, but we omit it to keep our examples small and instead assume customer names are unique. Okay, so we are not assuming that customer names are unique. So in order and we are not using customer ID here. So how to distinguish with the combination of customer name and customer street. So here one very important concept comes into picture, that in a super key there may some extraneous attribute. Extraneous attribute means which if we omit those attribute, then still the database can distinguish two records of itself. Okay. Now K is a candidate key if K is minimal super key. Means from the super key, if we can remove the extraneous attribute, then it become the candidate key. Example, suppose I am saying customer name is a candidate key for customer since it is a super key and no subset of it is a super key. So by removing the extraneous attribute of a super key, we can get the candidate key, right? Now next is primary key. So the largest is super key. From the super key, by removing the extraneous attribute candidate key, and from candidate key we can get what? Primary key. Okay, super key, candidate key, and then primary key. Primary key is a candidate key chosen as the principal means for identifying tuples within a relation. Okay, minimum number of attribute required in a candidate key or minimal candidate key which can distinguish between any two tuple of a relation should choose an attribute whose value never or very rarely changes. Okay, the values which are fixed, rarely changed, we used to take those attribute as primary key. Okay, example, email address is unique but it can may change or it may change. Okay, now one very important concept, that is foreign key. It is based on the concept of referential integrity. Now what is the meaning of this? You come to know. A relation So in simple words, I am just saying that uh, attribute, a attribute which is primary key in the other table is called as foreign key. Okay, suppose I am saying I have two table, A table and B table. In A table there is one attribute X, clear, which is primary key of the table B. Then in B, X is the primary key, but X is, column is present in A also. So in table A it is not primary key. Now in table A it is called as foreign key. So in table B, X is primary key and same is present in table A. So in table A it is called as foreign key. Okay, so in other words, in simple words, we can say the attribute or the key which is primary key of another table is used as a normal attribute, then it is called in the another different table or different relation, then it is called as what? Foreign key of that particular another table. So a relation schema may have an attribute that correspond to the primary key of another relation. That attribute is called as foreign key. Okay, so primary key of another table used as normal attribute in a current relation is called as foreign key. Example, suppose we are having customer name and account number attribute of depositor are foreign key to customer and account respectively. Why? Suppose in customer relation, customer name is there and customer name in customer table is primary key. Similarly, in account table, account number is the primary key. So what foreign key definition tells, says that in account table, account number is primary key which is used, account number is used in depositor table also. So in depositor table, account number becomes foreign key. Similarly, in customer table, customer name is primary key and customer name is used in depositor table also as normal attribute. So customer name will become foreign key in depositor table. Okay, so only values occurring in the primary key attribute of the referenced relation may occur in foreign key attribute of the referencing relation. Okay, so if you see, this is the banking scenario. Step by step we will be understanding this. See, first relation is branch. In branch, branch name, branch city and asset. Three attributes are there. Among these three attributes, branch name is primary key of this branch relation. Next relation is account relation. The relationship we will be focusing after understanding all the individual relation. Next relation is account. In account relation, there are three attributes again: account number, branch name, and third one is balance. Account number is the primary key of account relation. Next relation is depositor. In depositor, if you see, there is no primary key. Okay, and in depositor table, it doesn't have its own attribute. Means in depositor table, whatever the attribute are there, customer name and account number, these all the attribute, these both the attribute are the primary key of another table. Suppose here customer name is the primary key of the customer table and account number is the primary key of the account table, right? So we can say that depositor is the referencing relation and account is the referenced relation. Clear? Parent table is account and customer, and depositor is just referencing account number and customer name from those particular parent tables, right? Next, customer table. In customer table, customer name is the primary key, customer street and customer city non-prime key attribute. After that, we are having borrower relation. If you see, next relation name is borrower. In borrower, there are two attribute: customer name and the loan. So in borrower relation also, customer name is the foreign key because customer name is the primary key of the customer table, right? So it is referencing to the customer table, as well as second attribute is loan number, which is the primary key of the loan table, loan number. In loan relation, there are three attributes: loan number, branch name and amount. Loan number is the primary key attribute of the loan table, but it is referenced from by which table? Borrower table. So in borrower table, there are two foreign key. In depositor table, there are two foreign key. Now, if I want to summarize depositor table, then we can say depositor table contain those customer name with their account number who are having the account in the bank, right? Similarly, in borrower table, it is having two entries of the foreign keys, customer name and loan number. So borrower table is having those customer names which borrowed some loan from the bank. So there are six tables in this particular database: branch, account, depositor, customer, borrower and loan. Branch table, standalone table with three attribute: branch name, primary key. Amount, standalone table, account number is the primary key. Customer, standalone table, customer name is the primary key. And loan, standalone table, loan number is the primary key. Now you depositor is just used as a relationship between the account and customer. So it is a relation or table for the relationship. Branch, account, customer and loan are for the entity, and depositor and borrower are for the relationship, right? Now query language, a language in which user requests information from the database. If you want to access some information from the database, then we need to provide some certain step or some certain instruction need to provide to the database. So those instruction in collective form is called as query language. Now there are various category of a language. In case of queries, procedural and non-procedural. Non-procedural means, as the name implies, we are not just telling the procedure of the query, or it is just a declarative language. Now there are some pure languages also existing in a database, like relational algebra, which use some notations or some symbols are there, like sigma, pi in the relational algebra. Tuple relational calculus, domain relational calculus, these all are based on some expressions, right? Now pure languages form underlying basis of query languages that people use. Okay, so professionals use the we can say relational algebra, TRC and DRC, but SQL or non-procedural language, that is declarative, that is a structured query language, is generally used by all. Now in relational algebra, there are some, it is basically a procedural language. It means we need to tell to the database in the query that what procedure we need to follow in order to get the required information. So basically there are six operations are there, six operators are there. First is select, that is sigma. Third is second is project, pi, union, u, set difference, minus, Cartesian product, cross and rename, that is row. Total six basic operators are available in relational algebra: select, project, union, set difference, Cartesian product and rename. All these operators are used for different purposes. So the operator take one or two relation as input and produce a new relation as a result. So we need to provide in input the relations, either one or two relation or more than two relation, and from those relations, inputted relation, it will query will be processed, query evaluation engine will do the task, optimization will be there, okay, and at the end it will produce a new relation as a result, right? So in this lecture we are discussing about the select operation. So if you see, the original relation is having four column A, B, C and D, and in this table we are having four rows. So in first row, corresponding to A, alpha, corresponding to B, alpha, corresponding to C, 1 and corresponding to D, 7. Similarly, alpha, beta, 5, 7, beta, beta, 12, 3, beta, beta, 23 and 10. So this is the original relation, right? Now if you want a relation where the D column value are greater than 5, then we need to, with help of the select operation, how to write down. So the name of the operation or symbol of the operation is sigma, and here we need to write down the predicate, and in the bracket we need to write down the relation name. So here the name of the relation is R, so in the bracket R, name of the operation sigma, and the condition is A equal to B, A and B value should be same. So if you see in first column, alpha alpha, and third column beta beta, but and fourth column also beta beta. So if you see first condition A equal to B, it means first row satisfied, second row alpha equal to beta wrong, beta 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 beta. First, third and fourth row, according to first condition, first, third and fourth, three rows are selected, but end D should be greater than 5. Fourth column value should be greater than, so in first row again it is accepted because 7 which is greater than 5. Third row 3 greater than 5 wrong, so third row also omitted. So second row already omitted, third row already now omitted. So first and fourth row will be occurring in the output relation. Okay, so in the output relation, 4 column and first row and fourth row will be entered as the output relation. Okay, so that's all from this particular lecture. In the upcoming lecture, some more exciting concept about the database we will be learning. So till then, thank you so much.